Hi everybody and welcome back to Human Systems Engineering 542. Today we'll be talking about human-computer interaction. And, used to be when we talked about human-computer interaction, we were talking about the devices that I'm sitting at right this minute, like a computer or a laptop or something like this, but computers are far more ubiquitous than that these days. We, of course, have them on our wrists. I'm looking at my Apple Watch here. We embed them in our running shoes. We carry them in our pockets. Basically, computers are everywhere. And this is important because the user interface, the thing that you guys are focused on designing, ends up being much more than the screens and so forth that we see on laptops and desktops and so forth. Instead, it refers to everything that the user comes into contact with. So that'll include things like the screen and the keyboard and the trackpad and all of those kinds of things. It'll also include the graphic user interface. But the thing is, that's really just a subset of the overall user interface and refers largely to the graphics and the menus and so forth. And in fact, the advent of the term user experience was largely focused on getting away from thinking about the user interface as simply those windows and buttons and things like that you see in front of you on the screen, but to mean more everything that the user comes into contact with. So that's really how these two things are related, the user interface and the user experience. The user experience in the term was largely a reaction to people just thinking about the user interface as kind of the components of a screen, when in fact we were talking about so much more. So speaking of the user experience, here's what it means. It refers to all of the effects felt by a user when interacting with the device. And the issue is that, of course, a user experience can't really be designed, but has to be sort of felt by the user. It's actually the user who's having the experience. You can facilitate that experience. You can make it better, hopefully. Sadly, you can make it worse, too. But it's the user's experience that's happening. So the best you can do is kind of improve or create a positive, or facilitate, really, a positive user experience. And you do that through really thoughtful design. It doesn't happen by accident. Just doesn't happen by learning new technologies or new prototyping tools and things like that. In and of itself, it happens through really thoughtful design and thinking about the total effects that a person comes into contact with. So the components of a user experience, typically when we're thinking about a user experience, it includes several different things. There's the product's usefulness, its usability, and its emotional impact. And the emotional impact is really during the actual interaction with the product and even the memory after the interaction. So all of those things are components of what we're trying to facilitate here. So let's start talking about, remember I said usefulness and usability and so forth. The usability is the practical component of the user experience. This is kind of where I started off in design, and I was really interested in designing products that were easy for people to use. That was usability. So that meant they had to have 4 characteristics. They had to be easy to learn, they had to be efficient to use, they had to be remembered pretty easily, and they should be resistant to error. And, heaven forbid, somebody makes an error, they should tolerate that error and help them out in fixing that error pretty easily. So if usefulness provides the device's functionality, usability provides easy access to that functionality. And then you'll notice the other thing I mentioned was kind of emotional impact. That's part of the user experience as well. That's the affective component of user experience. So that will include things like trust and confidence and pleasure and aesthetics and all of those kinds of things. Even it can involve things like self-identity and pride of ownership and so forth. So my brother and my brother-in-law have an ongoing good-natured argument. One drives a Ford truck and the other drives a Chevy. So they'll refer to themselves as, I'm a Ford person and I'm a Chevy person. This gets to the difference between do goals and be goals. What I mean by that is do goals are those components of a user interface that are kind of evaluated by how well something enables us to do things. And the fact is that Ford truck and the Chevy truck probably do those things pretty much equally well. That's kind of the pragmatic or the practical quality of it. But then there are big B goals, and that refers to our emotional needs. So I'm a Mac person, for example. I tend to use the Mac, and I tend to kind of have emotional attachment to that thing. So that's wrapped up in my self-identity. You see this, for example, in people that are willing to do things like tattoo a Harley-Davidson logo on their body or a Nike logo or something like this. It's part of their self-identity, and it's one of their ways of relating to others. So, for example, I drive an older Jeep that I take out usually during the winter, and sure enough, as I'm driving around in this older Jeep, everybody who else is in a Jeep waves to me. I often forget to wave, not because I'm a mean guy or anything, but simply I forget that kind of thing. But that's part of sort of belonging to this Jeep club. So self-identity and these emotional components and kind of belonging is a big part of the user experience as well. So now that we've covered those kinds of components of the user experience, remember kind of the usefulness, the usability, the desirability, those do goals and those be goals. Now let's talk about some design principles. And these principles are based on sort of perception and cognition. They're not really rote recipes or hard, fast rules, but lots of times, in fact, you'll need to violate one principle kind of to achieve another. And this points out to an important part of design. It's a continuous exercise in trade-offs. Each design decision seems to carry an advantage and a disadvantage, and your job as designers is to figure out which of those two things is going to carry the day, which one's going to be more important. So let's talk about some of these principles. One is to support mental models. So a mental model is really a person's way of thinking about a device, about the purpose of the device, about how it works, things like that. Included amongst that is designing the UI. So that would include the information architecture, the layout, the nomenclature, in other words, the wording of buttons and labels and things like that, messaging, etc. All of those things can help or hinder the development of appropriate mental models. It's also facilitated by making organization visible, simple, and understandable. So it's typically easier to understand if the product has fewer elements. So actually one of the things that Norman brings up often is sort of the discoverability that's involved in a user interface. So can I find what I need? And the understandability. Do I comprehend how things work? And you can help the development of mental models by ensuring users can always answer these questions. So how do we go about supporting people's mental models? Let me go back a second here. Yep, as I said, there's sort of two important qualities of any user interface. There's the discoverability, can I find what I need? And then there's the understandability. Once I've found what I need, can I actually understand how things work? And of course, you can help the development of these mental models by ensuring you can always answer these questions, or at least your users can always answer these questions. So they should be able to answer questions like, where am I in this design? Make sure that people know where they are and where they've been in the user interface. They should be able to answer, what can I do at this moment? Make sure that people understand the actions available to them. You can use things like, I don't love long labels in helping people understand what they're doing, but sometimes they're not necessarily bad because they can add precision. The idea here, when you're trying to be as minimalist as possible in your user interface, is to avoid extraneous words. You can also make sure that people understand what has been done. That is, keep users aware of task progress, what's been done so far, and what's left to do. Also make sure users know how to return to the home screen. Make sure they understand the meaning of each user interface component. There shouldn't be something up there that they shouldn't be able to figure out. Use the language of the user rather than technical jargon, and technical jargon has a tendency to creep into our user interfaces whether we want them there or not. So it takes a lot of effort to make sure you're sort of speaking the user's language rather than the technology language. Make sure that people understand how it is they are supposed to be doing things. So if you can provide informative clues to indicate how each interaction works, that would be wonderful. And make sure that you're using a positive tone of voice. So avoid things like violent or negative or demeaning terms like illegal or invalid or abort or things like that, that at least the old school programmers used to like to use a lot. Allocate tasks wisely. What I mean by that is there's certain things that humans are good at and certain things that computers are good at, and it makes sense to make sure that you allocate those things accordingly. So people and computers have strengths and weaknesses, and they tend to be complementary. People tend to be good at creative thought, planning, etc., whereas they're bad at complex calculations, storing and retrieving information, and doing the exact same thing repeatedly. Computers, on the other hand, are really wonderful at calculations and remembering information. They don't get tired, they don't get bored like humans do, but they're bad at creative and supervisor activities. So it's really important to choose which tasks and activities your user is going to do and which ones the computer is going to do. And that really takes some thinking and planning through of this. So here's just a quick example from the book. Humans tend to be better at understanding based on sensation and perception, adapting to novel conditions, choosing alternate plans, all of those kinds of things. Additionally, try to make your user interfaces of all kinds consistent, which tends to reduce confusion. I don't know why that word facilitates is there, but pay no attention to it. Consistency also includes consistent sequences of action or similar types of functions, consistent labeling, consistent use of colors and graphics and button shapes, and consistent placement of information on your user interface. Also, help people minimize memory load. So we've talked many times before about working memory, which is one of the two bottlenecks in cognition. The other, of course, is attention. But by minimizing people's memory load, it enables them to recognize objects and items rather than needing to recall them. It can be facilitated by using familiar labels and icons and interaction styles, and make sure that you group related items. All of these things make it so people don't have to remember so much in their minds. Make sure you provide informative feedback, which I've kind of alluded to before, but that feedback should be consistent and timely, etc. That includes providing system status, like is the product running, is it doing anything with my input, etc. It helps make users feel confident that their actions actually worked and understand, why it didn't work in those cases where it didn't. It should be easy to see. It should be placed within the user's focus of attention, usually right in front of them. One of the problems about status message lines is they often don't work if they are not right in front of people. So sometimes, you've probably experienced this, a status message will be somewhere in a corner and people have no idea that it's even there because they're focused on another part of the screen. Instead, pop-up messages, which are right next to the cursor, that is where your action is happening, would be way more noticeable than some kind of status line. Go out of your way to make sure that tasks are efficient. So that means eliminate unnecessary steps, provide automatic completion where possible, provide formatting hints, and so on. And you can see, although not very clearly here, some of these formatting hints. So you can see under the phone number here, for example, it indicates that, well, the area code is supposed to go here, followed by the exchange, followed by the actual number. Same thing with the email address. It provides an example, and so forth. And down here as well. You're just telling people the format of things that go in there so that they don't have to try to remember this themselves. Your job largely is to provide just the information necessary that enables people to conduct their tasks. And that means everything else is kind of extraneous. So at each part during your design of your user interface, you're going to be consistently asking, hey, do I need each little bit, each component here that's on this screen, or could I get away with making it disappear, basically, making it so that there's less information on the screen. Here are some things that one can do to prevent errors and to handle errors should they happen. So you can prevent errors by things like graying out inappropriate actions, doing things like enabling people to select items rather than typing them where they can make mistakes in typing, providing automatic completion during text entry, etc. We can also provide the ability to reverse actions by undo, for example, and we can make error messages as helpful as possible in some of the ways we described before, but certainly in a way that's positive in tone and constructive. Here we're going to talk just briefly about interaction styles. These determine how users work with or communicate with the device, and different interaction styles are appropriate for different types of tasks. One of the things I've found is it's important to group similar interaction styles together. So for example, if there are several things that require form fill-in, typing, etc., put them together so that you don't have to have the user move frequently from the keyboard to the mouse input to the screen input, etc. They accomplish several things that are highly related in terms of input all at once. So you can see here's an example where we've done this. Here's a positive one and here's a negative one. You can see in the negative one we have people typing in text, and then we have them selecting items, and then we type in more text, and then they select items. Instead, we're better off grouping all of those things where they type in the text first, and then they do mouse selection, and then maybe they type in a little bit more text at the end. It just makes it so that they're not moving between those two things as often. Over on the left-hand side, we've got a few other important pieces of information for designing good form fill-in types of user interfaces, providing meaningful labels, making the length of the data entry field roughly the same as the longest expected text, which tells people about how long they should expect things. Left justify text in data fields, also left justify labels on data fields, and either place them directly to the left or directly above the field. There's some formatting related to numbers in the data field that's listed here as well. One of the things that I have found helpful is in the design of these types of user interfaces, and you've got these text boxes, for example, I will usually only include two sizes of text box. And the idea is if we had 5 or 6 different sizes of text boxes, it ends up looking really complex, much more complex and messy than it needs to. Whereas here, 2 sizes kind of accomplish everything you would need to do. Limit the number of menu items in your menus to about 6, which tends to reduce search time. It can be increased, however, if you do things by, like separating lines or dividing lines between those two things. In that case, people kind of go to the part of the menu where they expect to see it, and then they look within that part. So basically, it's a way of chunking these things. Here's another situation when I'm talking about aligning things for decimal points, for example. So over here, you can see some problems here. Here we've got temperature 98.6, etc. But this thing looks a bit busier than this one down here. Here the labels are centered, the decimal points are not aligned, and the units are not aligned. So you can see that here. Whereas here, just by justifying and aligning those things, it looks much more legible. Direct manipulation, of course, is just dragging and dropping and treating things as kind of visual objects as if they would be that way in the real world. It also uses metaphors like desktops and folders and things like that. And if you think about what the whole desktop metaphor is about, it really is about 2 things. There's containers and there's documents. And those documents can be, various kinds of things, of course, but if you think about, your desktop and your file folder and or your file cabinet, and then your file drawer, and then your file folders, and then folders within folders, and then folders within folders within folders, all of those things are just containers. And within that, eventually, you get down to the kind of the leaf level, at which point you have a document of some kind. It could be an app, for example, but a document. The nice part about that is that tends to match the user's mental model of how things are organized pretty well. And that ends up being really useful and one of the benefits of direct manipulation. There are also input methods like gestures and multi-touch, in which case you use more than one finger to read gestures such as pinching and spreading, and that's of course most useful on touch screens. It enables users to zoom in and out and navigate from one screen to another. And this can even be done without touching the screen, of course. This uses kind of motion tracking technology to capture arm and hand movements. I think there's some important things. In fact, this is suggested by Lee and his colleagues in their book, but it talks about some good multi-touch gesture design. Make sure you provide cues to signal which gestures can be used and what function the gesture is for. Make sure the gestures are easy to perform. Do what you can to minimize fatigue and stress associated with repetitive use, and ensure gestures are easily differentiated by the computer so you don't confuse one for the other. Of course, one type of interaction style is the simple dialog box. One of the nice things about the dialog box is it captures your attention, and it typically won't go away until you've done something here. So here's an example which is really important for a medical product where it's dispensing a particular medication, and you want to make sure people are really aware of a drug interaction. A really important part of user interface design has to do with information architecture. And information architecture is really making information findable and understandable. It reduces the likelihood of information overload, makes the product more enjoyable, etc. It enables people to find the information without going through a bunch of unnecessary stuff. But it requires from your part a lot of structuring, a lot of organizing, a lot of thinking, so that you can sort of figure out what goes where, what gets grouped together, and how to discuss this stuff. That is, how to label it. And if you can do that, you go a long way towards designing a really good product. Doing good information architecture results in those positive things that you would expect. Basically, faster, more efficient performance and better user satisfaction. One of the big decisions you're going to need to make when you're doing information architecture is thinking about the depth versus the breadth of that information architecture or that information structure. There's often a trade-off between the depth and breadth of, say, a menu system. So there's a deep structure that has few options at the top layer but requires the user to go through several layers of menu to complete their task. There's also shallow menu systems that has more options at the top level but requires traversing fewer levels. Generally, the shallow structure is preferable. It gives people a little bit better of a bird's eye view of the whole system and can improve the user's understanding of the system by showing everything at once. It also reduces the likelihood of burying functionality that people need if they go down the wrong path, for example. So in order to design these shallow menu structures, the top level has to be pretty darn well organized, and the options arranged according to kind of importance or urgency, frequency of use, and then grouped according to relatedness. Here are some other ways of thinking about information architecture. These are ways people have of, kind of navigating a menu structure. So here you can see a linear structure. This is something you might have in an automatic teller machine if you're taking out your cash, or something like buying movie tickets or buying concert tickets. In this particular case, people aren't doing this all day long, so it makes sense to sort of give them a linear sequence. This makes it so that it gives them as much guidance as possible. They have very few opportunities to make mistakes. Now, kind of a branch from that, I didn't mean to use that term, but another alternative to that is to use branching. And what that means is perhaps you've got a first couple sort of items where you really guide the user through, but then they get to a point where they can choose a few different options, and then from that they go a little bit further. And in that particular case, you're providing them with some guidance, but not complete guidance. They have a little choice in this. And then more often, you'll have a networked approach, and you can see that where there's multiple ways of going multiple paths. So the linear approach tends to reduce the likelihood of skipping steps, especially if you got interrupted, and is really helpful for infrequent users. The branching approach presents a greater variety of options, probably more useful for experienced people or people who use the system frequently. And the networked approach is similar to the World Wide Web, frankly. Basically, and it's kind of like a toolkit. People can do more or less whatever they want. The problem is you don't give them as much guidance. They have to figure things out a little bit more themselves by exploring. Now let's talk a little bit about screen layout. What I mean by screen layout, of course, is arranging items on the screen, which influences people's ability to locate items. It also influences their ability to understand the meaning of the items, how things relate to one another, basically their mental model. It also affects your ability to provide an attractive, well-organized, professional-appearing product. Screen layout, as well as information architecture, has a lot to do with how people categorize the information they encounter. And as I said before, people naturally and spontaneously do this. This is an important part of our cognitive life, is categorizing things, which we do whether we like it or not. It's also the case that kind of the default categorizations that humans kind of apply to everything in the world is a hierarchical kind of categorization scheme. And that has a lot to do with, as I mentioned before, the notion of things in containers. We can often describe things in the world as hierarchical components. And it just indicates a matter of belongingness. This belongs to that, and that is part of something bigger, which is in turn part of something bigger. So basically, reflecting these logical categories and these hierarchies is important in user interface design. You need to make sure that the most critical items are placed in the most conspicuous position on the screen. That's one of our ways of helping attention, for example. This tends to be toward the upper left in large screens and tablets, but on smaller screens, we tend to focus more in the middle of the screen. So in that particular case, you might want the most important information not in the top or upper left-hand corner of your device, say an iPhone or something like that, but instead should be more towards the center. One of the ways or tools that people use in order to make well-organized kinds of information architecture in screens is to provide a grid. A grid breaks up an area into units and kind of makes things much more consistent and better arranged and so forth. It increases legibility and readability, it improves consistency, it helps guide people to understand what they should be paying attention to. And if it's used, that is the same grid across multiple screens, again, that increases sort of the predictability. People know where to look. Importantly, sometimes items can violate the grid, and when that happens, it attracts our attention. So when that's the case, that could be a really great situation if you need to attract somebody's attention, for example, to report an error. Simply the fact that it's different than the rest of the layout on the screen attracts our attention. Remember, typically things that change or things that are different than the background tend to attract our attention, and that's exactly what's happening when you violate that grid in certain situations. So here's an example. A grid can contain many or few columns. A simple one-column grid, of course, is often used in text. So for example, when you're writing your responses to exams and things like that. But a complex grid with several columns can be used for pretty complex content. So for example, a newspaper with a lot of different articles or something of that sort. Tall and narrow columns tend to be easier to read than short, wide rows, largely because the distance required for the eye to travel is shorter. And then the notion behind these columns is they can break up the grid into smaller units. But interestingly, those smaller units don't necessarily have to have content in them. So you can see that over here. Here's a situation where we've got different margins and so forth, and this down here is adhering to this up here. And you can see there are parts in here where there's not text, and that looks just fine. On the other hand, over here, this is a situation where they're not really adhering to a grid very well. And boy, does that look much more, confusing or complex than what's going on over here. Of course, a big part of this and using the grid is to provide adequate white space or blank split space And this basically makes the screens easier to read. It separates blocks of information and it helps guide our attention. It chunks information so that we know there's only a few different places on the screen to look. And we can accomplish some of this just by gutters and margins and padding. And you can see the margins, when we talk about that, that's kind of the things surrounding the text or the activity. The columns are the components in the middle. The gutter separates the columns, and the padding basically is space within a column that separates it from the edges. And this just makes the design quite a bit easier to read. But you can also see that these are this is kind of your toolkit for laying out information. Are these grids? Within these grids, the components, the margins, the gutters, the columns, and the padding. That's all kind of what you have to work with when you're laying out screens. Now, when I say that, it doesn't mean you don't have other things like text size and contrast and color and all of those kinds of things. But often laying this out first makes all of that other stuff a whole lot easier to deal with. Make sure, speaking of which, make sure that you select font styles, font sizes, contrast, resolution, and other things so that people can read these things. So for example, sans serif fonts are those that don't have extra details like hats or feet on them. They tend to be easier to read on computerized displays. They tend to be more difficult to read on paper, but easier to read on computerized displays. And these include things like Arial and Helvetica and a variety of others. It's also important to use scalable fonts with a moderate degree of anti-aliasing, which provides a smoother appearance. And we talked briefly about color, and I've talked about it before in the sensation and perception sections, so I'll just touch on it briefly here. Color nicely conveys meaning. It can help separate blocks of information. It, of course, provides visual interest. It makes our displays a heck of a lot more interesting. It can elicit emotional responses. The problem with color, if there is a problem, is that it's so powerful. It tends to draw our attention. If it draws that attention to really important items, that's great. If it draws that attention to items that are extraneous, well, that's terrible. So you really want to you want to be really thoughtful in your use of color and help it to sort of organize displays and so forth. So here's a couple guidelines for color. I think, as I've mentioned before, I typically design screens using those components that I talked about a little bit ago, the grid and so on, and think about white space and gutter and columns and so forth before I ever start entertaining the notions of color. So that enables me to do things like create simple and clean aesthetics. I tend to use color pretty sparingly, but because I use it sparingly, when I do use it, it has great effect. I tend to design for monochrome first. I'm consistent in color coding and so forth. I try to adhere to common expectations about color codes. So that is, people tend to have different kinds of thoughts or beliefs about what different colors represent, and I try to adhere to those. Here's an interesting thing, however, that results from the use of color when it's used poorly, and this is called chromostereopsis. So chromostereopsis is a situation in which basically two colors are at opposite ends of the visual spectrum. So for example, blue and red. One of the things that our eyes are, well, main thing our eyes are tasked with doing is to provide a very sharp image on our retina, and in particular on our fovea. Well, in order to do that, the lens has to bend for different types of wavelengths. And because the blue and red are at opposite ends of the visual spectrums, their wavelengths are very different. So what that means is when I'm looking at blue, my lens is flattening or becoming more concave or more convex depending on the wavelength. And then when I look at red, the same thing is happening, but it's going in the opposite direction. So what that means is my lens, when I'm looking at these two things together, is becoming more concave and then more convex and then more concave and then more convex. And that ends up providing this sort of weird effect called chromostereopsis. That is, it almost gives it a look of some depth, and it's very fatiguing to the eyes because, of course, the ciliary muscles are what control that lens and their muscles, and as a result they'll get fatigued very quickly from becoming convex and concave time and time again. That's hard to explain. I'm glad you bore with me during that. You're patient. I appreciate that. Okay, here's an example in the design of tables, and you can see some pretty positive things with this table over here. This is a patient log, as you can see, and people read columns of data easier than long rows, and you can facilitate that by kind of alternating the text here so that the shades of the text here. You can also draw attention to things by providing a little dot here, which indicates some type of status that's not clear from this particular display. But you can see this is an awfully simple looking display, much simpler than you would see in many patient logs. One of your biggest challenges is going to be displaying small displays or designing small displays, because they often have so little room in which to display information. So small devices often have very focused functionality and few selectable areas, and these things are getting smaller and smaller as time goes on. So some simple tips for this is to really understand what's the most important thing you're trying to display and make that easily legible. To reduce or eliminate data entry as much as possible, to make sure you're including the most frequent and important information front and center, to make sure people understand what's selectable and what's not, to leave room for scrolling and swiping gestures, and to avoid inadvertent actions, and basically relegate less important functions to other platforms like desktop computers and everything. You don't need to be able to do everything from your watch, probably just the most important and frequent things. Towards the end here, we'll be talking a little bit about design metaphors, and you have a pretty good idea probably what these are about, but they're basically visual representations of real-world objects. And the most common ones that you run across, of course, are desktops and spreadsheets and notebooks and index cards and checkbooks and things like that. That's basically what design metaphors are, and the nice part about those is it helps people to understand how to interact with things kind of immediately, because they're already familiar with how to interact with something similar. All of this information should be provided in some kind of UI guidelines that are critical or important to your specific design or your particular platform. So basically, when you document your UI guidelines after you've designed these things, you can make sure other people who are contributing to it are adhering to your initial design intent. So that helps you get a common look and feel. It makes it easier for people to learn. It makes it more predictable. And basically developers then spend less time considering each UI decision because you've kind of laid out for them what it is they ought to be doing. I think I've mentioned this a few times, and I tend to harp on it, is just how important message design is and treating people well in your messages. So use messages when people need to respond or make a decision, when they need to correct a data entry, when they need to confirm a destructive action, like eliminating data or deleting data, or when processing takes longer than, say, 5 seconds, or longer than a user might expect. That's a time to present a good message. And that message here, whoops, there it is, should be brief and concise. It should have the most important information at the beginning of the message. It should use an active voice. It should avoid technical jargon. They should use short words, they should avoid intimidating words, and they should order prompts chronologically. So first do this, then do this, then do that. Mainly what you want to be able to say in an error message is to provide 3 pieces of information: what the user did, why it was wrong, and how to correct it. And for God's sake, don't blame the users when you're doing this. Avoid negative wording. These folks have been kind enough to buy your product, and you want to keep them around to buy the next one. So do not make them feel bad. Do everything you can to be supportive. So use help on error messages as well, which will help people understand how to use the product. So that is a discussion of human-computer interaction. I hope you found it helpful, and I will look forward to talking to you in the next video.